Hello everyone, I hope you're doing well. So in this video, we're going to discuss the first 5 problems of Codeforces Round 888, which was written for Division 3. So I was trying to solve the F problem, but unfortunately, till now I didn't have any luck. So for this video, I'm just going to discuss the first 5 problems. Let us quickly start with the first problem. So the problem statement is pretty big for the first problem, but I'm just going to explain you what is the key idea or the summary of the problem first, and then we'll look how we can solve it. So let's say they're saying that they have given us an array of heights. So if you have been given an array like this, right? So each of them would be at certain levels. So let's say this is at level 1, this is level 2, this is level 3, level 4, level 5, level 6, level 7, right? So what is the difference between these two levels? What is the difference between the height of these two levels? It will be 5 minus 3 multiplied by k. So 5 minus 3 is the difference in the indexes, right? And k is the difference with each step. So if you're moving 2 steps, 1 and 2, you will be having a height difference of 2k between these two steps. So they have actually represented it as a staircase where the height difference between each consecutive stair is k. So if you have some stairs 2 distance apart, the distance will be 2k, right? Or the height difference will be 2k. Now they are saying that we have to form, or we can form pairs such that the difference in the height of the stairs, that means let's say this is at 3 and this is at 6. Now if this difference in height is equals to the difference in height of the people standing on those stairs, then it is a valid pair. So let's say the absolute difference between x and y is x minus y, like this, and it should be equals to 6 minus 3 multiplied by k, right? So this will be the difference in the height of the stairs, of these two stairs, right? And we have to take the absolute of x minus y, right? So this will be the height difference of the people standing on it. So now we have a main character, let's say it is person A, right? And we have been given the height of some people in the array. So we have to tell with how many people this particular person A can form pairs in the original array of height that has been given to us. So this person can only form a pair with one of these people. Let's say one of these people has a height x, right? So the difference between these two heights will be person A's height minus x, right? So we have to take this absolute value. Once we know that this is the difference in their height, now this difference should also be some multiple of k, because we want both of them to stand on some stairs. It is totally up to us. We can choose any stair, but in order for them to stand at 2 stairs, first of all this height difference should be divisible by k. So this value mod k should be equal to 0, right? Because whenever we are finding the difference in the height of the stairs, we are multiplying it by the value k. So this should be divisible by k as well. Now once we know that it is divisible by k, you need to understand that there are two other things as well. So the first thing is, what is the maximum height difference that we can have between any two stairs? So let's say there are 7 stairs here, right? So if there are 7 stairs, what you can do is the maximum height difference you can have is 6k, right? Because if you choose this index and this index, then 7 minus 1 multiplied by k would be 6k. So this is the maximum height difference you can have. So if absolute of PA minus x is greater than or equals to this value, let's say m, right? So this is the maximum index of state that you can have. If it is greater than or equals to this particular value, then your answer will be false. One more thing, that the height of the person should not be equals to height of the person x, right? Why? Because they both cannot stand on the same stair. So these are the 3 conditions that you need to check to find out whether this person A can form a pair with the person of index I. If he can form it, then we will increment our count by 1, otherwise we don't update our count value, right? So let us have a look at the code now. So what I've done is, I've taken all the inputs. So n and m. N is the number of heights that we have been given to us, and m is the maximum index of the stair that we can have. K is the value of the difference between two adjacent stairs, and h is the height of our person A, right? Now we take the input in a vector v, and I initialize my answer with 0. So I'm just traversing through this vector V and I'm finding the difference between the height of the current person that has been given to us in the vector input and the height of my person A. So if this dx is greater than 0, so this is the first condition, and dx mod k is equals to 0 and dx by k is less than n, right? So these are the three conditions. If all of them are satisfied, I'll increment my answer and at the end I can just print my answer, right? So remember, these are the three conditions that you need to check. When all of them are satisfied, only then you can form your answer. So this particular problem says that we can swap any two elements ai and aj such that it is not the same index I and j, and ai and aj should be either both even or odd, right? So what they're trying to say is we have been given a permutation and we can only swap the elements which have the same parity. Now the question further says that we have to sort the array in non-decreasing order by performing any number of operations, and we have to find whether it is possible or not. So the answer will be yes or no, right? So they have also given us an example, but let us discuss some of our own examples. So let's say you have been given an array, right? So let's say this value is 3, this value is 1, and this value is 2, this value is 7, this value is 6, and this value is 9, and let's say 5, right? So this is the array that has been given to us. Now I can swap this and this element because the parity is same on both, right? Similarly, I can swap this and this, 1 and 7, and I can also swap 9 and 5, right? So let's say you have the elements like these 3, 1, 7, 9 and 5, right? So you can swap any two elements among these elements, right? You can swap any two elements. And if you are able to perform any number of swapping operations, you will realize that you will always find a way to arrange this sequence in non-decreasing order like this, right? So let's say you swap these two elements, so it will become 1, 3, 7, 9, 5. Then you can swap these two 5 and 7, and you can form 1, 3, 5, 7, 9, and then you can swap 7 and 9, you can form 1, 3, 5, 7 and 9, right? So you see there will always exist a way to swap the elements such that it is arranged in non-decreasing order, right? So this part was very simple to understand, that if you can swap any two elements in this particular sequence, you can always arrange them in any order you want. So similarly, we can do the same thing for the even numbers. Let's say 2 and 6. In this case, they are already arranged, but let's say 6 and 2 are present like this. So you could have swapped these two elements and still form 2 and 6. Even if there are more number of even elements, you will always be able to arrange them in increasing order. But the problem is, you can arrange the odd numbers among themselves. You can arrange the even number among themselves, but you cannot swap an even number with an odd number. So what we'll try to do is, we'll store all the odd numbers separately. We'll try to store all the even numbers separately. We will sort them independently, and then we're going to traverse through the original array. So if the current index is an odd index, I'll take the smallest element from the odd vector. If my current index is an even index, I'll take the smallest element from the even vector. If the current element is an odd index, I'll take the next smallest element from the odd vector, and keep on doing this, right? So at the end, what will happen? All the even places will have their elements in sorted order, and all the odd places will have their elements in sorted order. If the final list that we get is already sorted, then the answer will be yes. Otherwise, it is never possible to sort the final array. Why it is never possible? Because there will be a case, right? Even after sorting all the odd elements and all the even elements independently, if we don't get our answer, there definitely will be a case that an odd number which is of smaller value comes after an even number which is of greater value, right? So there will be a case like this, and since we cannot swap these elements, the answer will be no. So let us have a look at the code now. So you will see what I've done is, I created the original vector and taken input in the vector, and I've created two vectors, odd and even, and both of them are just going to store the values, right? So if the current value is odd, I'm going to store it in the odd vector, otherwise in the even vector. Now I can just sort both of the vectors. So I have sorted them in reverse order. Now what I do is, I just traverse to the vector, and if the current element is odd, I'll update my current element as odd.back. So remember, I sorted the vectors in reverse order. So my smallest element will be at the back, and then I can just pop back the back element. So this will really help me to just get the last element or the smallest element in O of one time, and I don't have to maintain any pointer separately to take care of what are the elements that I have traversed. So that is why I use this method. I take the element from the back and pop it back from the vector. Similarly, I do the same thing for the even numbers. If the current number is even, I update the current number with the smallest even number and I just pop back that particular element. Now, if this vector V is sorted, then the answer will be yes, otherwise the answer will be no. So this was the solution to the second problem. Now let us have a look at the third problem. So this particular problem says that we have been given some tiles of different colors, right? So we will be starting from the first tile and we will be ending at the last tile. Now we have to choose some tiles such that if let's say we choose p number of tiles, it is divisible by k, right? We obviously have to choose the first and the last tile, it is compulsory, and the path is divided into blocks of length exactly k. And they also say that each block should have the same color. So if we are dividing the whole chosen tiles into blocks of length k each block should have the same color. That means all of the tiles in some particular blocks will have the same color, and the colors in the adjacent block are not necessarily different. So they can be same or they can be different as well. Now what you have to do is, let's say you will have to choose the first and the last tile, that is for sure, that is compulsory, and that means your first block that you will have the color of the first tile, and the last block that you will have the color of the last tile, right? So this is one part about the question. Now since you have to take blocks of size 3, so what you will try to do is, you will try to take these 3 blocks with the color same as the first block, and you will try to take these 3 blocks with the color same as the last block, right? So this is how they have done in this particular problem. If the first color is red, they have taken 3 indexes which have the red color. If the last index is blue, they have taken the last index or the index with the same color as the last index, right? So I believe till now you must have had some idea of this particular problem. If not, we'll discuss how we can solve this. So let's say you have an array like this, right? So let's say there is some blue color here and there is some red color here. Now I want to find a block of size k. So one thing is for sure, that my first block should be of blue color and my last block should be of red color. So let's say I was able to find a blue color here, and a red color here, right? So I can choose these 3 indexes and these 3 indexes to form 2 blocks. If I am able to find 2 blocks with these 2 colors, then there is no need to fit any additional block in between. We might be able to fit any additional block from here, but it is not at all necessary since we don't want to increase the number of blocks, right? There is no constraint on increasing the number of blocks. So if you are getting 2 blocks, we are happy with it, right? So as soon as you get these 2 blocks, you're just going to give your final answer. Now, how do you identify whether such a situation exists? So for this, you can choose something like a suffix sum. So what will the suffix sum store? So suffix sum is going to store, let's say for any index I, it is going to store the number of elements with color same as last element in range I to n, right? So in this range, it will store, suffix of I will store the number of elements with the color same as the last element, right? So let's say that at this particular position, suffix of I will be equal to 3. At this particular position, suffix of I will be equal to 2. At this particular position, last position, suffix of I will be equal to 1, right? So as soon as I encounter 3 elements or k elements with the color same as the first index, I'll try to find what is the value of suffix of I plus 1. As soon as I find this is equals to 3 or this is equals to k, I'll try to find suffix of I plus 1. If this value is also greater than or equals to k, then my answer will exist, otherwise my answer will not exist. Why am I stopping at this particular index? Because you will see what is the property of a suffix array. If we are at this particular index and if you try to move forward, the values are always going to decrease, right? The values are not going to increase. So if the answer is not possible at this particular position, it is definitely sure that the answer will not exist at these positions after it as well, right? So that is why I am trying to choose the first index where I complete the constraint on my first color. That is, I find k occurrences of them. As soon as I find k occurrences of them, I'll try to find the value of suffix of I plus 1. If it is satisfying that suffix of I plus 1 is greater than or equals to k, then I found my answer. Otherwise, I have not found my answer. So this was all about the problem. Now a very special case, a small case that we have to discuss. What if both the front and the back colors are of the same color? Now in this case, you don't even need to form two blocks. You will be fine or good enough with only one block. So you can choose one block with the same color. So in this case, whatever the block or whatever the color is at the first and the last index, its total frequency should be greater than or equals to k. Right, if it is greater than or equals to k, you can definitely form your answer, because you can always choose those k blocks, any k blocks among them, and you can form your answer. So in these two cases, the answer will be yes, otherwise the answer will be no. So let us have a look at the code now. So you will see what I have done is I created a suffix vector, and I'm just storing, I'm creating a reverse for loop, and I'm updating my suffix of I as suffix of I plus 1 plus v of I is equal to v of n minus 1. That means if my current element is equals to the last element, then I'm going to add 1 to my answer. Now if both of these values, the first and the last index, are equal and suffix of 0, so suffix of 0 is actually going to store the total frequency of this element that is present at the first or the last position. If it is greater than or equals to k, then my answer will be yes. Otherwise, in the other case, what I do, I initialize my count with 0 and I'm just going to traverse through all the elements. So I'm going till less than n minus 1, and I'm going to increment my count whenever my element is equals to the first element in my array, that is the element of the 0th index. So if this count is greater than or equals to k and suffix of I plus 1 is greater than or equals to k, then my answer will be yes, and I can just return from here. Otherwise, I can finally print no. Right. So in this loop, why am I going till only n minus 1 or less than n minus 1? Because I have to check a condition for I plus 1. If I go till n, this I plus 1 will go out of bounds, and since the value of k is at least 1, then my answer will definitely exist till n minus 1. If it doesn't, then the answer will be no. Right. So let us have a look at the next problem. So this problem is prefix permutation sums. So this problem says that there was initially a permutation of size n and its prefix sum was calculated and passed on to you. But unfortunately, one of the elements is missing from the prefix sums. We have to find out whether this prefix sum can correspond to some original permutation that might have existed. Right. So what we essentially have to do is, so let us discuss this with the help of some examples. So if we have this with us, so the first step, the very first step would be to extract the permutation from this particular array. So this is the prefix sum array, and let's say a of I is equals to v of I plus v a of I minus 1. Right. So this is how the prefix sums are calculated. Now what we have to do is, in order to extract the original array, so the first element in the original array will be equals to the first element itself. Right. Now for the second element, it will be equals to the difference between these two elements. So in this case, it is 2. Right. So the second element would have been 2, the third element would have been 4, and the fourth element would have been 3. Right. So this is the updated permutation that we would have got. And this permutation, some elements will very well belong to the range, that is in the range 1 to 5, we have no problem with them. But some elements might be, I'm saying some elements might be bigger than the possible range, that is 5. Right. So what is this possible range 5? Since we are considering a permutation of length n is equals to 5, there can be no number that can be greater than 5. So one possibility why this number is greater than 5 is that this could have been actually two different numbers. That means, let's say these were the original numbers, 2, 4 and 3 are already completed. Now this could have been two different numbers, 1 and 5. But when we were calculating the prefix sums, this would have been taken as 1 and this would have been taken as 6. Right. And then this element was removed. This is one possibility of what could have happened. This is the only justification that can explain that this number is greater than the value of n. Right. There can be no other case in which this value should be greater than n. So that means if any number is greater than n, so definitely some number is missing from this particular permutation, and this particular number is actually going to store the sum of the two missing numbers, right? So this is case 1. So case 1, when we retrieve the original permutation from the given prefix sum array, you will find if any value is greater than n, that means this value should be sum of missing two values, right? And you will realize that there will exist exactly one of these numbers, right? As soon as there are more than one numbers like these, then the answer will never exist, because there was exactly one element that was deleted in the original question, right? So since there was only one element that was deleted, only one of the elements would have been in a state like this, where it is performing or it is representing actually the sum of two numbers, right? Now case 2 is like when none of the values is greater than n. So we have discussed that they cannot be more than one. We have discussed what happens if they are present exactly one time that the value is greater than n. What happens if there is no value that is greater than n? So in that particular case, let me just form a test case. So if the value of n is 4, right? So let's say this is the permutation and this prefix sum will be 2 plus 3 and 6, right? Now in this case, you will see this will be the prefix sum that will be given to you in the input. When you try to calculate the values, original values, these will be the three values 1, 2 and 3. So if the size is 4 and you have already encountered 1, 2 and 3 and you have not encountered any value greater than n, that means if all the values are less than equals to n, so if there were initially n values, there are n minus 1 values that are less than equals to n, so you will be remaining with only one of the final values, and you can always append this final value to the end of the permutation, right? And this will be a valid permutation. So we have discussed what happens when there is no value such that value is greater than n. So in this case, the answer will always be possible, since you can always append it to the end of the permutation. Now in this case, the missing value was equals to 1. In this case, the missing values were equals to 2. Now in any of the cases, if the missing values is greater than 2, so how do we calculate the missing values? Let's say we are maintaining a data structure like a set. So as soon as we encounter any value less than equals to n, we remove it from the set. So at the end, we'll either have one value in a case like this when there is no value greater than n, or we will have a case like this where we will have exactly two values that are missing. Why? Because this one value that we'll have will compensate for those two values. Because we are going to break down this particular value into those two values, and it will be only possible if this particular value that is greater than n is actually equal to the sum of the missing values. So in this case, the answer will be yes, otherwise the answer will be no. So you have to deal with a couple of cases and you will be able to find your answer. So let us have a look at the code. So you will see what I have done is I've created a vector v of size n minus 1 and I've taken input in the vector. Similarly, a vector t of size n minus 1. And I've created a set which is going to store all the elements from 1 to n. Right. Now I'm going to store what is the extra value that I have. So I'm going to traverse through this t vector. If I is greater than 0, that means it is not the first index. I'm going to update my t of I as v of I minus 1. Otherwise, t of I will be simply v of I. Now, if t of I is greater than n, or I have already removed this particular t of I from my set, that means I can set this value as extra. So this is some extra value that I have, right? Otherwise, I'm going to erase this particular value from my set. Now what I do is I initialize my need. So this is the value that I need, and I already know what is the extra value that I have. Now I'm just going to add all the values in my set. So if the size of the set is greater than 2, then the answer will be simply no. And now if the value of extra is equal to 0, extra is equal to 0 means the case that we discussed where all the values in the vector t were less than equals to n, right? So there will be exactly one value remaining that we can always append at the end of the vector, right? So this is the first case. or the value that we need is exactly equal to the value that we have in extra, right? So in this particular case, the answer will be yes, otherwise the answer will be no. So this was the solution to this particular problem. Now let us have a look at the final problem of this discussion. So this problem statement is also very big. Let me just explain this to you quickly. We're going to take this particular sample test case. So what they're trying to say is, so let's say these are the cost of buying certain medicines, right? So this is the cost vector. So 30 is the cost of buying the first medicine, 8 is the cost of buying the second medicine, 3 is the cost of buying the third medicine, and so on. Now you have been given this value. Let's say this is K. So this means you have K medicines that you can completely use for free. You have unlimited supply of them. So after the first cost vector, there will be K values which will represent that these are the medicines that you already have. So let's say this vector is have. You already have these medicines and you can always use them for free. You have an unlimited supply of them. Now these are some medicines 1, 2, 3, 4 and 5. What you can do is, this medicine requires or depends on 3 other medicines. So now this question says that this medicine 1 depends on 3 other medicines and these are the indexes of those medicines, right? So in order to make the medicine 3, you need 2, 4 and 5, right? You need these medicines. So actually there are 2 ways of procuring a medicine. The first way is that you can buy that medicine directly from the shop which already has the cost vector, right? Or you can try to make it on your own using these 3 medicines. So at the end we will have to output an array which will consist of 5 indexes and each of the index should denote the minimum cost to procure the ith medicine. So I've already said it to you, there are 2 ways of having a medicine. Either you can prepare it using the recipe that you have or you can buy it. You would obviously want to choose whichever of them is cheaper. Now the problem is that we are not discussing this example now. We are going to have a look at some cases. Let's say you have some medicine 3 like this and it depends on some other medicine 2, right? So let's say this depends on medicine 2. Now this particular medicine depends on some other medicine, let's say 1, right? So in order to make 3, if you want to prepare 3, that means you want to use the recipes and you want to prepare it, then in that particular case you will have to first prepare 2. In order to prepare 2, you will have to first prepare 1, right? So for 2 again you will have 2 options. Either you can try to prepare it or you can buy it. For 2, if you want to prepare it, you will have to prepare 1 first. And also let's say this is 3 depends on 2 different medicines, that is 1 and 2. So if you buy 1 to prepare 2 first, so this medicine will be used and you cannot use it again here. So if you want to prepare 3 by using 1 and 2 and you also decided to prepare 2, then you will have to buy 1 2 times. 1 for directly preparing 3 and 1 for directly preparing 2, right? So you will have to buy for them separately and you cannot carry it over, right? So this was one important thing. But now this problem must seem somewhat similar to you, because we are seeing that each medicine is dependent on some other medicines. So whenever there is a dependency graph or a dependency structure, we use a technique called topological sorting. So if you are already familiar with topological sorting, then this question will be very easy for you. I'm still going to explain how you can apply topological sort in this particular problem and let us see how. So the topological sort says that, let's say we have some nodes like these and each node will be dependent on some other nodes, right? Like this, let's say. So this is the node that does not have any dependency. This node has a dependency from this node and so on. So that means, so each directed edge here is showing that I need to prepare this particular medicine first or I need to complete this particular task first in order to complete this task and this task, right? So for each node, I can try to find out, or for each medicine I can try to find out what is the cost of preparing that particular medicine, right? And I already know what is the cost of buying that medicine. Whatever of them is the minimum will be the final cost for that particular medicine. right? So how do I find the cost of preparing the medicine, right? So let's say initially all the cost of initial are initialized to 0. I'll start with this particular node. Since this node doesn't have any dependency, I'll try to form this particular medicine. So if I already have this, the cost will be obviously 0. Otherwise, the cost will be equals to the cost of buying this medicine, right? Now, since I can use this medicine to prepare 2 other medicines, I'll go to these 2 nodes, right? I'm going to these 2 nodes, and for each of those nodes, now since they already had only one dependency, I have already prepared this, so I can find the cost of preparing this. Otherwise, I'll take the minimum of whatever was the original cost of buying this medicine. Whatever of them is minimum, I'll take that particular cost. Now you will see that this particular node depends on these 2 different medicines, right? So the cost of this particular node will be equal to the cost of the first node and the second node. So the summation of both of them. Now let's say this cost was x plus y, right? And the cost of buying this medicine was z. So the final cost of this medicine will be minimum of x plus y comma z. Now how do we actually perform topological sorting? So the key idea will be very simple. So let me just explain you with the help of the code, because it is much easier to explain. First of all, what I have done is I have taken 2 integers n and k and taken input in the vector a of size n. So this is actually going to store the cost, and I also have a vector have. So this is going to store which are all the medicines that I have. I am decrementing x by 1 because I wanted to take 0 based indexing. So I create a graph and an integrity vector. You will see in a while why this integrity vector is important. And for each of those nodes, I have q dependencies. So I just traverse through those q dependency. I take input and I just push back x. I just push back I in the graph of x. So that means I need to first form x, only then I can form I. Right? This is how the dependency works. Now I will increment the integrity of I. Now I have a q and I have an answer vector. For I'll traverse through all the elements, and whenever the integrity of I is 0, that means the current medicine does not have any dependency. So in that case, I'll just push that particular medicine into my queue. And if I already have this medicine, then my cost will be equal to 0. Otherwise, my cost will be equal to A of I. Because if I don't have it, I have to buy it, and there is no other way of preparing it. Now, I'm just going to traverse through my queue. While my queue is not empty, I'm just going to take the front node and I'm going to traverse through all the children. So I'm decrementing the integrity of my child, and I'm updating my answer of child as answer of child plus is equals to answer of node. So basically, if my child node depends on the current node, so I'm going to add the cost of the current node into my child node, right? Because in order to prepare the child node, I need to use the current node and I need to add its cost. What is the significance of this particular line? That if integrity of child becomes 0, integrity of child will become 0 when I have resolved all the dependencies of this particular child, right? So let's say this is your medicine and it is depending on 2 other medicines A and B, right? So what is essentially happening is the integrity of this particular node is initially 2. Now I add the cost of A to this particular node. So let's say it is cost A, right? And since this dependency is resolved now, I can remove this edge, so my integrity will become 1, right? So in a way, I am saying that I have removed this edge. Now I come to the node B. I see that this particular node C is depending on node B. So I'll add my cost of B, right? And since I've already added its cost, I can remove this dependency. So the integrity will become 0. That means I have removed all the dependencies on node C, and now I can process this particular node. So as soon as its dependency or its value becomes 0, integrity becomes 0. In this case, I'll check if I already have this child or if I already have this medicine with me in the given input vector, then answer of child will be equal to 0. Otherwise, answer of child will be minimum of answer of child comma cost of buying that particular child, right? So you see, I'm taking the current cost, that is the cost of the medicine by preparing that particular medicine, and I'm taking the minimum of this particular value and the value or the cost of directly buying the medicines, right? These are the only 2 ways you can prepare a medicine or procure a medicine. Now, when you have repeated this answer value, you can just push this particular new medicine into your queue, so you can further process it. Now at the end, you only had to print the answer vector, and this was all about the final problem. I hope that you guys were able to understand the solutions. If you guys did, then consider dropping a like on this video, and don't forget to share thoughts and comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you and you'll be able to reach more number of people like you who want to keep solving new problems. So I see a lot of people who watch these videos have not subscribed yet. In case you're one of them, then definitely consider subscribing. It's always free of cost, and you can always unsubscribe if you don't find the videos interesting later. So share this channel with your friends. Until the next video drops, keep coding, stay safe, bye bye.